Hi, welcome to the Data Tech. So today we are going to discuss about how to train your own tokenizer. So before that, we just have to see what is tokenizer. So I already made a video about LLM tokenization design, and that video link is there in the description box of this video. So I recommend you to watch that video first. But here again, I'm going to give a heads up of what exactly the tokenizer is, and then we can jump into the topic. And we do have practical as well at the end of the video, and this video will be little bit a lengthier video, sorry for that, but worth watching, so you will not be get bored, and I give guarantee for that. Fine, let's get into the topic. So what we are going to discuss about today is all about vocab and merge. So these are the two important files that you need to train for your own tokenizer. Okay, so let's first talk about the tokenizer as I told you before. So the high level of connecting with LLM, right? So your question, so let's take about chat GPT. So your question that goes to the model. So model is something the brain for the LLM, right? So this model is something in GPT. If you use GPT, we have transformer, that is the core model. So this is a model by Google. They have released it. The white paper has been released in 2017 and it is open source. You can use it. So GPT used it. They did a lot of fine tunings and then they have enhanced it, and then they are using the model transformer. And your model will give the output finally, right? So this is what the high level of how actually we communicate with the chatbots, like AI chatbots like ChatGPT or Gemini or any other form of LLMs, right? So now where exactly this tokenizer comes into picture? Okay. So now imagine that you are asking, who is Gautam? So this is the question that you are asking, right? So this question will not directly goes to your transformer model, because your transformer understands only numbers and we otherwise called as token IDs. Okay. So now what as a LLM before the model, okay, even before it comes to the model, there should be some system that converts this text to a number so that the transformer model understands it. And that process is called tokenization, converting the string. The question could be anything, right? It could be a numbers or characters or the combination of both, right? So it's like a string. It has to convert it to a number, and that process is called tokenizer. Okay, let me just erase this. Now let's talk about tokenization. What is tokenization? As I told you, your string will be converted to a token and then a number will be assigned for the token, and that process is called tokenization. Now imagine, like I say, who is Gautam? Now this is the sentence that you are sending to your LLM model, right? Input. Now what this tokenization process will do? It will split this into a word, subwords or words, and then it assigns numbers to it. Like for example, 78, 18, 272, something like this. And this number is the input for the transformer model. Okay. So here, this particular process is called the token process, and that is again comes under the tokenization. Now the question is how this number is generated. Okay. So now this tokenization process has a dictionary. Okay. It has a dictionary, and this dictionary will have all the words, okay, with the token IDs. Imagine like already it has who, was, when, something like that, are, is, Gautam. Okay, there are so many words. So this dictionary has so many words. Okay, so here it will have some numbers. For example, 78, 27, 100, and then is 18, 272. Now, whenever some words come as an input to your chat GPT, and this tokenization process will split this into token and refers to the dictionary, and we call this as a lookup process. It does a lookup, okay, and it comes to know, okay, who is 78, is 18, and Gautam is 272. So this is what it does. And this part, so this the complete part, we call it as tokenization. So the creation of dictionary and maintaining the dictionary. So this part and this number generation, it's all done by an algorithm called BPE, Byte Pair Encoding. So there is an algorithm which does this complete process, Byte Pair Encoding. That again comes under the topic of tokenization. Okay. So what exactly this byte pair encoding does, I'll tell you in detail, But before that, I just wanted to tell you a few things. Now imagine if this dictionary, okay, so this particular dictionary doesn't have the word who. Okay, now imagine it has a word as WH and O. Okay, but not who. It doesn't have one single word as WHO. Instead, it has WH, which is something like number 7, and for O, the number is something like 29. Just imagine, there is no 78. Okay. Now, when the sentence comes into picture as an input, it first checks, okay, is there, 18, Gautam is there, 272, it does all the lookup. But when it comes to who, there is no word who. So immediately what it does, it tries to split like this, WH and O. When the dictionary doesn't have the word, but the word is there in your incoming sentence, right? Then it will try to split the word again. It's like a subwords. Now imagine, okay, WH matches, okay, 7 and O is 29. Now imagine if what else if WH is also not there? Okay, then again it will split the word, the subword into 2 characters, WH. This dictionary 100% sure definitely it will have A to Z characters and as an individual character with token ID. For example, A, B, C, D, E, F, definitely from A to Z it will have, and some numbers also will be assigned to it. Okay, so but the problem here is, if there is no word or subword and finally it tries to assign and split it into individual characters, that means more tokens will be generated, and that's a problem for memory loss. Some problems could happen like memory loss for your model. So more splits of the token is not recommended. And that means this particular dictionary doesn't have enough words for the model to process it in an efficient way. And that means what to do when the who is not there, what to do. That means you haven't trained this dictionary properly or not with enough data. Okay, now all of a sudden you will get some question in the mind, right? So all we know so far is a training comes to the core model only, right? A transformer model in GPT or some other model in Gemini or Claude. So we train only models, right? Yes, but even before that, we have to train the tokenization. And one main process of training the tokenization is this dictionary. And technically, this dictionary is called as vocab. Vocab, and this will be in JSON file or it will be in a binary file. So the model which I used here is GPT-2 model. If you use GPT-2 model in OpenAI, then definitely the JSON file is, the vocab file is a JSON file. If it is more than GPT-2 like 3, 4, 5 means it's the vocab is a binary file. Okay, but by end of the video, I'll show you a practical, because transformer model is open source. So I'm gonna download the vocab file and I'm just gonna show you that the JSON file. Okay. So that means this particular dictionary, as I can say from now onwards, vocab.json was not trained. That means you have to train the vocab first and then only you have to train your model. So there is 2 types of training now. You have to just train your vocab file. Okay. Now the next question is, now imagine is, right? So is already there with the number 80. Now there is another sentence coming into picture. Is he available? Now next sentence. Now in this sentence also I have is. So there will be multiple duplicate is? No. It's always one word, one token. So whatever the word here, we call it as a token. And that token will always have the same number. Even 10 is comes into picture, is comes into picture, the value is going to be 80. Okay. So now how a token can be? Okay. A token can be a full word. A token can be a full word, for example, like who, is, etc. A token can be a subword. For example, we have ing, running, walking, swimming, that ing. For example, able, unable, respectable, right? So something like that. Or UN, unacceptable, unnecessary. So it can be a subword or punctuations. For example, question mark, comma, semicolon, etc. Right? So these are all called tokens. A token can be a full word or a subword or a punctuations or a special characters. Right? So now, the next part what we have to see is this vocab.json. Vocab.json. So what is the limit for this? Right? So if you take a dictionary, an English dictionary, right, it has a limit of 500 pages, 1000 pages, 200 pages, right? So what is the limit of this vocab.json, right? So if you take GPT-2, the limit is 50,000 tokens. That means this vocab.json will have 50,000 words, subwords, special characters. Okay, so this is 1, 2, 3. So this one could be a full word, this could be a subword, this could be a punctuation. So like that, it goes till 50,000. And that is what in GPT-2 they call it as sweet spot for the JSON file, 50,000. So most of the English words will be covered with this 50,000 is what they are saying. Now imagine the scenario like who the word is not there in this 50,000 token, and that means it tries to split it. So that means that particular dictionary, the vocab.json doesn't have. So I call it as dictionary like a typical kind of general purpose example, but actually technically we call it as an vocab. Okay, because these are all asked in interviews. Okay, so when you get into like AI roles or AI engineer, AI data engineer, right? So these are all asked in interviews in the system design level of LLMs. Okay, so technically it is called vocab. Okay, so now imagine like GPT-2 has only 50,000, but if you go for GPT-4 and GPT-5, it has limit of 128k token to 300k token roughly. So here 128k or 300k. Some models are supporting 300k, and that means the length of the size of this vocab.json will be 128k. So 128k means roughly giving a whole book as an input. And also when it comes to the limit of tokens, there is two places we have to see. One is when we say 128k token, and that means okay, this vocab.json will have only 128k words with IDs, and this is done by that byte pair encoding algorithm. So in Gemini also there will be such process, but it's a different algorithm. It's not DPE again, and then Claude likewise. Right. So now there is another thing when it comes to token. For example, you are chatting with ChatGPT, you are sending a text, a sentence with 3 tokens. Who is Gautam? And that is 3 tokens. Now imagine your ChatGPT responds back to you in 200 words. That means 200 tokens roughly. So that means in a single session, in the single chat, the input question plus the output answer, it is now total 203, right? So totally 3 words, 3 tokens is what your sentence is. The input and the output is 200 words. That means 200 tokens. So 200 plus 3, it's 203. So like that, in a single session, in your chat, in the single session, you can communicate with 128k tokens, but nobody does that. But again, like you can even upload a book and you can ask for summary, but that in that case, like 128k token roughly, it goes like that. And ChatGPT may say like, I have exceeded the token limit, etc. So when you come to know this number tokens, if someone tells you, it's not about the chat, also about the vocab.json file. Okay, so for ChatGPT-2 model, 50,000 is a sweet spot, and that's why like GPT-2 model lack of some words, and that's why they have enhanced it in ChatGPT-3, 4 and 5 models. Maybe in future models, the token limit may exceed also, right? So there are some model people are saying like it can even support 1 million tokens, right? So it comes in that way. Fine. So now, so already like GPT-2 model or 3 if you use, already the vocab file will be there. Okay, and if you download it, it will have 50,000. If you download GPT-2's vocab.json file, means it will already have 50,000. But what if I want to create a new, I want to train a new vocab.json file, right? How? First of all, GPT in ChatGPT OpenAI, they have trained this in the first places. They have given lots of Wikipedia content, words by scrapping the website, Word documents, PDF, and they have trained this vocab.json file. Now imagine if I want to do it from the scratch, an empty JSON file I have to train. I'll show you how to do that in practical, but then even before getting into that, I wanted to show you in theoretical aspect as well, right? So let me just remove all this. So we understood like what exactly happening in the vocab.json, what BPE does. It's all like, it's like trying to give a token ID. For all the tokens in the vocab.json, it gives a token ID, right? So now let's take one word, just one word, engineering. And now imagine we are in a phase of training a new vocab.json file. I'm not going to use the existing model. Now imagine I want to start and fresh. So I'm not going to teach you this BP algorithm practical line by line of code by code, nothing. No, I'm just going to tell you the design of that BP. But even in the practical, I'm not going to show you how to write a BP algorithm. The algorithm is already exist, right? But in interview, if someone asks you what is BP and what BP actually does, so you can just explain this to them, and you can even try to write a pseudocode based on what I have explained, right? And then you can say like, you can create your own JSON, or I can even download the existing JSON that I can reuse it. You can say like that, right? Fine. So let's take this engineering. Imagine this is the word that you are sending to your ChatGPT. Now, how the BP works is what we're going to discuss. And even before that, there is one more thing called merge. So to train the tokenization, you need two files. One is vocab.json and the merge file. The first the content will be get populated in the merge file, and then only it goes to vocab. But what exactly the merge file is, I'll tell you. So let me just write here merge.txt. And when you just send a word engineering, it immediately won't assign a number. Okay, engineering number 13. It's not like that. It does multiple iteration even for a single word. And finally, it creates a token ID. Okay. So now first thing, when the word goes, what it does, right? It splits each and every character as a token. Okay. But if you have noticed in my LLM tokenization video, I would have told you this. So you should not do oversplit. Individual character split, that is not recommended, I told you, right? But that is after creating the JSON file. Okay, but even before creating the JSON file, the very first step to create the JSON file, to train the JSON file, you have to split all your words and the sentence and the words into single character. Okay, and then only that iteration will start. Okay, so this is something even before doing a lookup with the vocab file to assign a token ID. It is even before that. Okay, fine. So now, because they are in a process of not reading, we are in a process of creating the JSON file. So it has to be start with single character, right? So from this, okay, imagine 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And whenever you give a word, it tries to take a unique word out of it, the unique characters out of it. So E, N, G, I, R. Okay, 0, 1, 2, 3, 4. So these are the unique words. So because again, like if you see E 3 times and then N 3 times, so G 2 times and I 2 times. So I just take only unique word. And now imagine like we have this vocab.json file. Okay. So E, N, G, I, R will be assigned with the number. Vocab.json will be get created. Because whenever you give a word, it takes unique characters from it and it will create the JSON file with a unique character. That's why I told you this vocab.json definitely will have from A to Z character wise, but it won't be in order. Whichever word comes first for the training, it will consider the characters and then it will assign the token ID. Imagine now I'm the next word is coming as elephant. Elephant. So now again, if you take E unique, L, P, H, N, T, right? So if you see here, E and N is already there. So it will skip. It won't even consider this E and N because vocab.json is already having it, right? So whichever the word comes first, based on that, the training will get started. Fine. So now what next? So vocab.json 0 to 4 is reserved already. Now what next? Now what exactly happened next to it, right? So this I will remove. This unique thing is just to create the JSON file. But now what actually the BPE will consider is, it will take this and it will create adjacent pairs. It will compare one character with another character. So it will create like this: E, N, N, G, G, I. So so this G again comes here. This I will comes here. So I, N, N, E, 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 R, R, I, N, N, G and G. Okay. So it will create this kind of an adjacent pairs. And what is the very first priority of BP is, it will check whether any pairs are repeating. For example, if you see NG is repeating twice and IN is also repeating twice. Now it will start checking from left to right. So if you write it in this way, so if you write it in horizontally, right? So left to right it checks. So that means from here to here. So it's like top to bottom approach. So first pair, matching pair is NG. So it will merge this N plus G, NG, and the merge file will have NG. That means merge file will have all the frequent merged pattern characters as a word or a subword in the merge file. Okay, and after this merge file is completely populated, it goes to vocab.json and where the IDs will be assigned. I'll show you everything. So it will be very interesting, guys. Now what about IN? So IN will not be considered. So this is the first iteration. So IN will not be considered. So in one iteration, it does only one merge. Okay. So now what will be the engineering, So what it will do, wherever it has this NG, it will merge it. So this 2 now it will be merged and I'll remove that comma here. So this 2 will be merged. So now it's like E, NG and I and comma N, comma E, comma E, comma R, comma I, comma NG. There is no comma between N and G now. So now I'll just remove this first iteration. If you want to check the previous iteration, you can go back in the video and you can check. So I will next start my second iteration. Okay, so iteration 2. Now it will be E comma NG and then NG comma I comma N, N comma E comma E, E comma R comma I comma NG and then NG. Right. So now it will check, is there any like frequent duplicate pairs available? So there is no duplicate pairs available here. So now what is the next thing it checks, is there any repetitive character in a pair? So that means if you see this is, so first BP will check any duplicate pairs or else within a pair itself duplicate characters. Now E. So E plus E equal to EE. Now merge.txt file will be populated with E and E will be merged and that means here this comma will be get removed. Okay, so first NG and now it's E. Now second iteration is completed. Now third iteration. So I3, the third iteration will be, so E comma NG, NG comma I and then I comma N, N comma EE and then EE comma R and R comma I comma NG and NG. So now what BP will check? It will check for any duplicate pairs, no. Any characters next to next duplicate character within same pair, no. Now hereafter it will start taking it in arbitrary order. It will take any one pair and then it will merge. For example, it takes this, imagine EE plus R. Now EER. That's all. So this is I3. Now again in I4, so this will be merged. So comma is removed, this will be merged. So that means like, so after E, right? So I N and then N E E R and E E R I comma N G and then N G. Right. So now there is no repetitive pair again. There is no repetitive pair and there is no duplicate character within the pair. Next it will take, for example, imagine it is taking this N plus E E R. That means N E E R. Okay. So N E E R. So for every iteration, it keeps on merging the file. Okay. So now what I will do is, so like this merge.txt will be created. And whenever this merge.txt is got created, it comes to vocab. So ng, for example, this is vocab.json. So ng will come here. Already 0 to 4 we have already allocated as a token ID for the unique letters. So that means now it's like 5 and then EE will be 6, etc. Now what I will do, I will show you the final vocab.json and then the merge file for your complete this word engineering. Okay. So let me just remove this. So now you can see here I have vocab.json and merge.txt. This is the final thing after the iteration you can see. So like already we have reserved it till 4. So this will not be there as part of the merge file. Merge file will have only whatever it is merged actually, the frequency of the data, the word, the subword. So now it starts from ng and finally these many iterations have happened and finally we got this engineering. So engineering is 13. So that means your engineering word, okay, so your engineering word, when it goes to your GPT model, the model will understand that as 13 instead of engineering. And now you can ask me like why we need this many iterations? Why can't directly like we give a token ID for engineering? See, that is how this has been designed, guys. See, now imagine there is a next, you are sending another word. So now I am sending data engineering. So for data, it does some merge thing. Imagine we forget about data. So engineering, it does this thing. Now I am just sending another word. Next day, I am sending engineering work. I am sending a word engineering work. Now here already this engineering has been iterated. It will skip this and it will do only for work. If work is also done, the JSON is completed, it will not check. Now imagine instead of engineering, I'm sending running. So in that, for this ing, we have already. So if you see here, we have already 12. So it will not do any type of iteration. It will skip. The more files, the more content you give, the words you give for this vocab.json for training, right? The more the iteration will be get reduced, and that is finally efficient only. If you see for one word, you can ask me why this many iteration is required. It's not efficient, but the more you train, right? So the more the iteration will be skipped. Now imagine if this ing is there. Imagine in some instant un is also there, r is also there, or unn is also there. Means it will skip the iteration. It will not create. So that the more you give, the more efficient it will be. Now I'm going to show you practically. So we are going to see some 2 to 3 samples with different scenarios. Let's get into practical. And even before getting into practical, till now, if you really enjoyed and you liked the video, please do comment that you enjoyed it, or I liked it, I enjoyed it, something like that. So I'll come to know that you are really interested in such videos, so I can make more such videos. There are so many topics in my to-do list. Okay, so let's get into the practical. And even before that, so these are the prerequisite. So you should have roughly like 3.10 version of Python, and then you can, so if you have multiple version of Python, then just install 3.10 as a virtual environment, and then activate it, and then upgrade your pip and install transformer. That's it. Now the very first code is, I want to download this vocab.json and then merge file, right? So I'm using this transformer model like from huggingface.com. So Hugging Face will have all the open source models. It's like a repo of open source models where you can download models from different vendors. So I'm just initializing my tokenizer with the pre-trained GPT model, and then vocab file path equal to cached files. Okay, so this will be this files will be available in the models as a cached files. And imagine like there may be a question comes, so where this vocab file will be get stored in physical, right? So imagine if they can ask you where this OpenAI for their chat GPT they store and maintain this vocab, means in their local servers, or it could be in a distributed file system, or in a local file system also, maybe in their database. Okay, so mostly like what the papers and internet says, they store it at somewhere in a distributed file system or in a local file system is what it says. But fine, like it is a file, you can able to see it. So now I'm just bringing that cached files of GPT to the vocab.json, and finally I'm just printing the path so that I can see this in my local file system. Okay, so let's run this. If you run it, it may take some time. That's okay, you can run this. Let's wait for the path to be get printed. So okay, so you can see here the path is printed. So it's the Hugging Face one. Okay, so till this you can copy. This ends with some 7e, right? It may be different for you. So you can copy this, because then it's the JSON file. So just ignore the file name. So go to your file explorer. Let me open one, and then just I will go to this path. See, you can able to see here the vocab.json and the merge file. Let me open these two files. So I'll just open this with Notepad. So since it's GPT-2 model, you are able to open it. So advanced model, like they said, like it is a binary file. You cannot open it. Okay, so I have merge file. So just forget about this G, and it has a dot on top of it. It's like a space which has been printed this way. So you can ignore it. Now this will have the merge pattern. So you can see here TH and REE is merged. Okay, and WITH and in is merged. Okay, so now imagine, let me copy this 3 and go to my vocab.json, and let me try to search for this 3. When you search here, you have to merge this, the space you have to remove, and then let me search. Yes, I do have it. See, I have it. So let me just put a count, and there is only one match. As I told you, once a word, a token comes, and the next, again, the duplicate will not be there. It's always 1, 3. That's all. So 15,542. Now let me take one word, one token from here, and I will try to search it in the merge file. Okay. So, but we don't know like what combination of merge it has, but that's fine. What I'll do is, let me just go with RAD. Okay, let me take this, and then I'll go to this merge file. Let me remove. Okay, so it's all selected. Okay, let me search for RAD in first place. Okay, so RAD. Okay, let me try to search
RAD. Okay, it's not there. R space AD. Yes, you can able to see here. So R space AD is there. And that means it has been merged and it moved to the JSON file. Right. So right, fine. So the next thing is I'm just going to show you how to get the size of the JSON what you downloaded. Okay, I told you it is 50,000. We have to cross check it, right? So let me just run this code. Okay, so this code will give the file size by just reading the file and then counting it, and then it will show the token size. Okay, I'm just use the length function and file read, that's it. So it's not going to be exactly 50,000. It's roughly, I think, 50,200 something is what the GPT-2 model. Yeah, 50,257 as I told you. Right, fine. So now I want to train my own vocab.json and merge file. Okay, here is the code and I include BP algorithm. I use the existing BP algorithm to do. So the very first step, I'm just initializing an empty token. So in BP, there are some reserved tokens. Okay, so you can see here in line number 15, these are called reserved tokens. And UNK means it starts with 0. That means imagine there is no token available. There is no such word available in the vocab.json, and they put that as UNK. It's like 0, starting with 0. And then like I'm just splitting all the spaces and everything for the merge file, and then I'm just training. So this is the training setting. So BP trainer vocab size, so I'm going to limit my vocab for 1000, and that's it, not more than that. But this is not recommended token size, but I'm just doing it for testing, right? You can even increase the size. And these are some special tokens will be already reserved with the token ID from 0 to 4. 0, 1, 2, 3, 4 will be there if you use GPT model. So padding, for example, like imagine you send 2 sentences with uneven length, and to just make a even length, it adds pad to it. It's the second word. Imagine the first word has the first sentence has 3 words, the second sentence has only 2 words. Since it's going in a same batch, it add one more pad to the second sentence so that it tries to make that length should be like 3 words, so it's like 2 sentences are matching. So it just add a pad to each of the sentence. And similarly, separator for sentence separator and word separator, and mask. So imagine I'm talking about Python, and finally I'm asking a question, I love dash, and that means the model should have the capacity to say I love Python, because I'm already talking about Python. So these mask and all you will be used in the training phase. So you can ignore this. So you don't want to you don't want to research more into these static special tokens, because this will not be there in other models if you see, but in GPT it has. And now this is my input word. So let me just open that file word.txt. Okay, this is my word. So this is the very first word I'm going to send for my training for the vocab.json file. So now I'll just run this. Okay, so here tokenizer.model.save, I want to save my vocab.json and then the merge file. So you can see here, I have those 2 files available here. Yes. So my BP, because I have given this my BP as a name, and merge.txt is the name which is generated by the code itself, the BP package itself, and similarly vocab also generated by. So I'm just adding a prefix file name as my_BP. Now when you run it, it creates these 2 files. It's got executed, it creates. So when I open this merge.txt, so it created all the merge thing, and then in JSON file you will be having the number. So for example, in merge file we have this IN, right? So here you can see the first tokens has been assigned for that special tokens, as I told you, the default one. And finally our in comes here. Yes, where it is. In. So for in, the token is going to be 19. Right. So this is how you can start training your own vocab and own tokenizer with the existing BP algorithm. Even you can write your own BP algorithm. Now you know the design of BP, what it exactly does. So you can write your own, but the Google and ChatGPT, you can get the help of Google and ChatGPT to get this BP algorithm. It gives you the algorithm. With that also you can train your own JSON file. And one last thing I wanted to tell you, when it comes to token limits, like, right, so for example, GPT-2 50,000 is good, but then if it is less than, imagine for the max 50,000 token limit of GPT-2, if you create a token for, like, for example, like 1,000, 2,000, it oversplits the character, so that means it does the hallucination part and then losing its memory. So this all will happen when your GPT model is not trained with an correct size of tokens. Now imagine that your token limit is 50,000, and when you try to train it for 70,000 or 80,000, and again you will see some weird words will be get formed without no meaning, and again that particular model AI will struggle to give you the answer. Maybe if some weird word, like it frames and then it gives you all of a sudden a different meaning, right? So it's all happen when you do that. So imagine whatever the model they are saying the limit, try to stick with that limit of training the vocab.json file, or you understand, if it is in your own model, you try to understand what the limitation resource that it accepts. In that way you can define your token size and you can prepare it in that way. Fine, guys, we are at the end of the video, and once again thanks for watching, and please do subscribe my channel and forward this to your friends and colleague, and do share my videos in LinkedIn as well, and that's a small help that I'm expecting from you. And my LinkedIn and my Instagram, all these IDs are available in my description box. You can follow me there as well. Once again, thanks for watching.